Alright guys, today we will be discussing about the doubly linked list, and here we will discuss about the operations of doubly linked list. Under that we are discussing about deletion operation. Okay, so here we will be learning three type of deletion, which is deletion of the first node, which is this particular node will be deleted and it has to be connected to the second node address so that this address will become second node address will become 200. So what happens is when we take the next node, connect we are going to delete any node present inside the linked list. So any position node we are going to delete it, and we are going to connect the node which for that you are going to delete this particular node, and this particular node I'm going to establish the connection. This is one thing I'll be doing it. And finally what we will be doing is we will be deleting the last node of the linked list. These are the three operations we will be doing one after the other. So let's get started with the diagram. If I jump into the diagram, you can able to see this particular diagram is all about doubly linked list, which has an element like 1, 2, 3 and 4, and head will be connected to the first node of the linked list, and the tail is connecting to the last node of the linked list. Is that clear? So now what we need to do is you need to delete this particular node. Which particular node? The node which is connected to the head. This node I need to connect. So what I need to do is basically I need to connect like this. This is what you need to do it. So this particular operation right now we are going to do it. For that we need to remove this address. New node, head is nothing but 200, right? 100 next part is going to be 200. So that we should make it happen. So for that what I'm going to do is initially let me check whether head is equal to null, tail is equal to null. If it is so, we will make it empty. This is the first condition that you need to do it. So let us start typing the code. For that I'm going to write deletion operation. So void delete in front or beginning, whatever. So whatever name that you want to give, you can give it. Okay, so inside this particular method, if I'm going to write a condition, if head will be equal to null and tail will be equal to null, then literally I can say my linked list is empty. So which is a list of, okay, a list of created. Okay, so system out dot println, you can write semicolon here, double quotes, L list is empty. This you can say it. Okay, so in the else part what I'm going to do is, okay, so now if this head and the tail, if it is going to be empty, then obviously we will not have any node. That is what I've written, the linked list is empty. But if it is not empty, then obviously it has to go to the else part, this part. No, so what we need to do is, this is what the actual execution is going to happen. So what I'll be doing, this particular node I need to disconnect, which means I have to connect head should be connected to the second node of the linked list. So what I'll be doing, basically what actually I'm going to do is, head is nothing but 100, right? Head is nothing but 100. So what I'm going to do, head dot next is what? Head dot next is nothing but 200, which is this one, 200. That 200 I'm going to store it inside the head. So which mean 200 will become this one, which is head will become 200, and this will connect it here, right? So once it gets connected, so what I am going to do is I need to make, now this node is my head node, right? Am I right? Head is equal to 200. So 200 dot previous I need to make it as null. 200 dot previous I need to make it as null. 200 dot previous, yeah, 200 dot previous, if I make it null, this connection will be a head dot previous will be equal to null. So which mean this becomes null, right? So this connection is getting disconnected. This connection, it is getting disconnected. So since we have connected here, this connection is also deleted. And okay, so from here only you can travel, so you cannot travel back. So when I'm printing from the reverse also, one will not be printed. So you can assume that this node is deleted. You can assume that this particular node is being deleted. So which means, let we start writing the code. You will understand how it is going to work. So let's see, if the head will be equal to, head will be equal to head dot next, and the last statement is going to be head dot previous, head dot previous is equal to null. So if you give this one, then I'm going to call the function before deletion. After deletion, I'm going to write it list dot delete in the front, call this function, and then list dot traversal. So I'm going to give this one. Okay, so let's run the code and we'll see. Oh, sorry, 1 minute. It is not going to the next line. So system dot out dot print ln. Okay, so now let me run it. You can see it goes to the next line. Okay, so before deleting, 10, 20, 30, 80, 40 and 50 is there. Now after deletion, 10 is being removed and deletion in the beginning of the linked list is performed. Okay, so next we will go to the next operation, which is all about deleting the node in the last of the linked list. Okay, so if you see this diagram, you have to delete the node in the tail one. So this particular node has to be deleted. So just give me a sec, I will recreate the entire thing, then we will execute what is given. All right, so now we have a doubly linked list, and I'm going to delete a node in last. Okay, which is nothing but your tail. Okay, this is what we are going to do it. Oh, sorry, it's hiding now. So bring this to the corner. Okay, so hope so you are visible with what I have done. Okay, so now what you need to do is, this particular node we need to delete it. How do you delete it? Very simple. Head dot, tail, this is tail, no, this is tail. Tail dot next is what? So tail dot previous is what? Opposite to the first one, what we have done there. Head dot next we have written here, tail dot previous we are going to write it. So tail dot previous I'm going to write. So tail dot previous we have given. So tail dot previous is what? 300. Am I right? So that is going to be connected. This 300 is nothing but this one, and that should be updated inside the tail. This is what ultimately we are doing. So tail dot previous has to be updated to tail. So tail will be equal to 300. So which is 300, which is getting stored inside tail, so that here we can mark it as 300. So what happens? Automatically this connection is being established. So tail dot previous, this I need to make it null, no, like this. So I need to make this part as null. So tail is what? Tail is going to be this one. Tail dot previous is going to be null. So which means two statement I've written. First statement, head dot, tail is equal to tail dot previous, then tail dot next, tail dot next next will be equal to, tail dot next will be equal to null. This is what you need to do. So if you do that, this connection is getting established, getting deleted. So if it is getting deleted, so automatically what happens, so from here you cannot able to iterate, because here it is null, so obviously you cannot able to traverse here. So this connection will also be disappeared, and you can assume this node is getting deleted. Is that clear? So these are the two statements that we are going to write it now. Just listen. Okay, so what is the next operation that we are going to do? It is deleting in the last. Okay, so take this one, paste it here. If head is equal to null, tail is equal to null, I can say the linked list empty. And if since it is going to be a tail, then I'll be making this is going to be tail, and I'm going to delete in the last. So end. Okay, so tail is equal to tail dot previous, tail dot previous, same thing, update reverse we are writing. Okay, so moving to the next one, then tail dot previous, sorry, tail dot next will be equal to null. Tail dot next, yeah, tail dot next is equal to null. So that's it. By this I can able to delete it. Okay, so I will delete now. End I'm going to write. So now let's see how the code runs. So last node which I have 50 is being removed in the second linked list, which is being pre-entered. The same linked list, it is seen after printing, before printing. So that is what we have in the code. So hope so you understood what we have learned today, and then followed with this we will do complete one more operations, which is deleting a node at any position. Deleting a node at any position, that is what we will be doing it. So now going back to the diagram, making you to understand how this particular operation is going to be executed. Okay, we'll erase it like this. Delete at any position. I have redo all these things. Okay, now here it has to be 400, and then this has to be 300. Okay, so delete all these three things, make it here 400 because it is connected to the last node. Okay, all right, so delete at any position. This is what we are going to do. So here we need to get the position. So third node I am going to delete it. The position will be equal to 3. The third node we are going to delete it. For that, what I am going to do is, if the head and tail will be equal to null, so obviously I can say it is an empty linked list, obviously. Okay, so that is what we are going to do. So let us get this piece of code, and I'm going to write this one. Okay, so at any position, in any position, that is what I have done. Okay, so remove all these things, so head is equal to null, tail will be equal to null, then I can say linked list is going to be empty. Is that clear? And then moving to the next one. So next thing what we need to understand is, we need to delete the node. So which node? Third node. So I need to get the position. So int position is what I am going to get it. And the next thing is, since it is not it's a deletion operation, you need not to get any node from the any values from the actual execution of the main part of the program or driven part of the code, which is public static void. I mean, you need not to pass any values, rather we need to pass only one thing, which is nothing but the position. Now I need to iterate. So what I need to iterate, first thing is, initially let me make this particular node as current node. Which particular node is current node? The first node is a current node. Now after this, so for that, what I need to do is, current will be equal to head. Okay, first node we made this current node, so from that we need to keep on iterating to the next position. So till this you will be iterating, because I am going to delete the third node. This node has to be deleted and this has to be connected to this one. Okay, so this is what I am going to do it. So till that we need to iterate it. For that, what I need to do is, so I need to iterate the for loop for 2 times. So for I is equal to 0, I is less than position. Okay, I is less than position, not 0. We have to keep it 1, because the current node is there in the first position by this particular statement. So I is equal to 1, I less than position, I plus plus. Okay, done. Inside this I need to iterate. So current will be equal to current dot next. Current will be equal to current dot next. So now I need to connect this 2 nodes, so which means this particular node and this particular node I need to connect it. That is what we are going to do it. Just listen. Okay, so now what I'm going to do is, consider there is a current node, current dot next, so which is current dot next is going to be 300. That is nothing but this particular node, right? So current dot, if you take this pointer, current dot next is this one. So I've already given, so this is current dot next is this particular node, which is nothing but this particular node. So now what you need to do is this node, current dot next. Okay, so current dot next is going to be 300. That 300 dot next is going to be 400. That 400 I'm going to copy this. Okay, I'm going to copy this and I'm going to store it here. This is what I'm going to do. I'm going to copy this and I'm going to store it in this particular index position. Is that clear? This is what we are going to do it. So for that, what I am going to do is, I'm going to write a statement, current dot, sorry, I'm going to store current dot next. Where I'm going to store? Here I'm going to store. Current dot next will be equal to current dot next. So which is 400 is being stored inside second node next part, which is 200 next part. We are storing it. Is that clear? So what happened is automatically getting this address and storing in this particular position. So we should face 400. So this gets connected here. Okay, so obviously this connection will be disconnected. Is it clear? So now what I need to do is, I need to get this is current dot, I need to get the address of this particular node, which is 400. I need to store it where, sorry, 200 I need to store it here. So which is current dot next is going to be 400, right? 400 is this particular node. 400 dot previous is going to be 300, and that particular address I need to there I need to store it 200. So what I am going to do is, just listen, I'm removing this address and I'm going to make it 200. So what happened? This connection will be established. So 2 lines I'm going to do. Current dot next will be equal to current dot next, then current dot next, current dot next dot previous, which is nothing but this particular position. I'm going to mark it as current. You're going to mark it as current. That's it. So that is what we are going to do it. So let's see, let's execute the code and you will understand how things are going to work here. Okay, so let's write the code. So node current, first node I'm going to make it as current node, and that is nothing but head. Head. Okay, the second line I need to iterate the current to the next position. So for that, what I am going to do, I will be equal to 1. You know why that I is equal to 1? Because we are there in the first position already, and then I is less than position semicolon I plus plus. Okay, so here I need to move my current to the next position. So current will be equal to current dot next. Okay, so the next one is current dot next. will be equal to current dot next dot next. I can write this line. Okay, so you know why? Because from one place to another place, the second node, the node which is going to be deleted after that node, we have got that particular address, and that particular address we are finding out from the this position, that particular address node. We're going to find it from that particular position. So for that, what we need to do is current is equal to current dot next we have written, and the next line is you need to find out the node which is going to be deleted. That after that previous part we need to check, because we already connected the second node with the fourth node, right? So that is what we are going to do. Current dot next will be equal to, sorry, current dot next dot previous will be equal to current. This is what we have done. So now let's see how a deletion operation is going to be performed. First we need to call it before and after. So here deletion, I am going to do it in any position. Okay, so I need to pass the value, so which is going to be 3. So third node has to be deleted. So if you run the code, third node is being deleted. Okay, wait, third node is deleted. The fourth node is getting deleted. So for that, what I need to do is, let me give -1. So if you give -1, so based on that it will work. See, if you check it, 30 is being deleted from the second linked list, which is being printed after deletion. Before deletion we have executed. So by this we would have understood, or you guys should have understood, that the deletion operation is performed in the doubly linked list. So by this we will wind up the doubly linked list topic, and the next topic we will discuss about circular linked list. Okay, thank you.